Hello. So we have here another topic. We'll be talking about sequence. So I have here two examples. The first one we have 1, 8, 15, 22, 29, and so on and so forth. Then the second one we have 4x, 12x, 36x, 108x, 324x, and so on and so forth. As you can see, our first two examples are known to be sequence. Why is it called a sequence? It's very simple because as you can see, both of our examples are showing a pattern. There is a pattern so that you could find out the next element or the next term. So looking at our first example, we have our 1. We have 8, 15, 22, 29. These are all known to be the elements of a particular sequence. And the elements of a given sequence is known as a term, as well as 4x, 12x, 36x, 108x, 324x. These are known to be the terms of the given sequence. It is a sequence because it shows here a pattern so that the succeeding elements can be found. When we define a sequence is a function whose domain or the set of positive numbers. So that's the definition of a sequence. It is a function whose domain is the set of positive integers or numbers. Now, there are two kinds of a sequence. We have finite sequence and infinite sequence. Our first example, what do you think? Is this a finite sequence or infinite sequence? I'll give another example. Let's say here we have 5, 25, 45, 65, 85. Okay, let us try to determine which among the three examples here can be considered as finite or finite or infinite. Okay, so let's have the first one. Our first one is known as an infinite sequence. Why infinite sequence? Because it shows here, we have here your sign of infinity, our three dots, which means to say that there is no definite ending. Together with our second example, we have here your sign of infinity, your three dots. That means to say that there is no last term. Our last term is not determined. While our third example, this is known to be a finite sequence. Finite sequence because we have 5, 25, 45, 65, 85. 85 is our last term. And this last term is also known to be your nth term in a given sequence. Okay, so all our examples here are known to be sequence because they're showing relationships or certain pattern so that the succeeding elements or the next elements or terms are determined by a particular constant. Okay, let's talk about the first kind of sequence, which is known to be arithmetic sequence. Okay, I'll give an example. Let's say we have here 3, we have 13, then we have 23, we have 33, and so on and so forth. Now, we are going to find out what is our 15th term, which is represented by a sub 15. Now, going back at our example here, from 3, 13, 23, and 33. This is an example of an arithmetic sequence because there is a constant wherein this constant can be it can determine the succeeding element by simply adding that constant. To find out the next element is simply using that constant being added to the preceding element. Okay, that constant is known to be your common difference. In arithmetic sequence, that is denoted by D, small letter D. This is your common difference. Okay, of course, here it is not yet known. Now, our first element will definitely be 3. So we're going to write 3. Now, the formula in finding the last term or the nth term or any specified term in a given arithmetic sequence is denoted by this formula. A sub n is equal to a sub 1 plus n minus 1 times d. Wherein our a sub 1, I already gave it, we have your first element. From this sequence, our first element or first term is known to be your 3. Then our n. Our n is the term which is being looked for. And our d is definitely our common difference. By the way, our common difference has a formula of d is equal to the difference between a sub 2 and a sub 1. So this is the formula. To find out the common difference is simply getting the difference between your second term and your first term. Or you can also use your third term and your second term. Or getting the difference between your fifth term and your fourth term. That is your common difference. Always remember that if we are talking about arithmetic sequence, you simply need to determine your common difference. For example here, our common difference in determining the 15th term of this sequence, our d would be, our second term is 13. 13 minus 3. So our common difference is definitely equal to 10. Now, remember that arithmetic sequence is a kind of sequence whose succeeding term or terms are determined by adding a particular constant, and that constant is known to be your d. Okay, let us now try to find out your 15th element from this formula. So getting the 15th term of this arithmetic sequence, we have a sub 15 is equal to, because we are looking for your 15th element. Remember that your n here would be 15 is equal to a sub 1. A sub 1 is 3. 3, just substitute the value of your a sub 1 using your first term in the given sequence, plus, of course, our n is 15. So we have 15 minus 1 times our common difference is 10. So now, we have a sub 15 is equal to 3 plus the difference between 15 and 1, we have 14 multiplied by 10. Simply simplify. So we have 3 plus 140. Then our a sub 15 is equal to 143. As simple as that. So this is now the value of a sub 15 based from the given example. As what I told you, your arithmetic sequence can be distinguished from the other kinds of sequence if your common difference between the different terms, they should be the same. For example here, the difference between 13 and 3, we have 10. This is also 10. And between 33 and 23, it's also 10. So if the common differences between or among the different terms are the same, then we call it an arithmetic sequence. Okay, so that's it. Thank you.